Okay, we are, as you can see, working Math 65, Section 6.5. All right, we're going to be just going over the general procedures for factoring a quadratic. That is a second degree expression. Okay, the first thing we always do, number one, factor out any greatest common factor, anything that each one of the terms has. Won't always have this, but if it does, you must get rid of it first. Excuse me, that was a sneeze. Okay, number of terms. If there are 4 terms, you need to factor by grouping. Okay, we'll get to some of those later, but you should remember how we've been doing factoring by grouping. 3 terms. If it's a trinomial, use either the trial and error method or factoring by grouping. Whatever seems to work for you. Okay, 2 terms. If there are only 2 terms, you're looking for a pattern. Is it a difference of squares? Yes, we use the pattern. Is it the difference or sum of cubes? If so, we use those patterns. Third, remember as a final step to examine the factors of the polynomial to see if anything else can be factored. If it can, you need to continue. And I would like to add in a 4th step, and that is to always check your answer by multiplying. Okay, now we're going to look at the flow chart we have, and this is an interesting flow chart, so I want you to understand how to use it. So when given a trinomial, so you know what we're going to do? Okay, so we have y squared plus 6y plus 9. Okay, so is there a common factor? No. So that means we go straight down. Notice it says no. If it said yes, you would, if there had common factors, you'd factor them out. That's what the yes direction tells you to do. But in this case, it's a no, so we go straight down. Now, how many terms in the polynomial? 2, no. 4, no. 3, yes. So we're going to follow that path, okay? Is it a squared plus 2ab plus b squared? Well, let's see. A would be y, b would be 3, 2 times 3 times y. Yes, as a matter of fact, it is that pattern. Okay, so that means, yes, we go this direction. And then we have our factor pattern we use. So my answer is going to be y plus 3 quantity squared. That's my answer. Okay, so this is how we follow a decision tree. All right, so we'll write it over here. 10y squared plus y minus 2. I think that's what that one was. Okay, so now we're going to follow this pattern, only this time I'll do it in a different color. We'll follow it in blue this time. Is there a common factor? No. So now I go straight down. How many terms in the polynomial? 3 again. So I follow the 3 branch. Is it a squared plus 2ab plus b squared? No. So that means we go straight down. Is it a squared minus 2ab plus b squared? No. All right, so now it tells me I should factor by grouping or trial and error. Okay, so this is again how we're going to be following these decision trees. We're going to go get with the first one here, y squared plus 6y plus 9. I'm going to the next one. Let's see. I'm just trying to grab one, like the one that's not as obvious. Let's just try the next one. 10y squared plus y minus 2, wasn't it? Yes. Okay. So, we have not factored number 2 yet, so let's do it. But we know we have to do it by trial and error. Okay, so that means, oh dear, I've got, well, 2 is prime, so I can only have 2 or 1. Now, 10 can be 5 and 2, or it could be 10 and 1. But they have to subtract to 1 when combined with 2. So 2 times 2 is 4. So if I put a 2y here, I get 4y. And if I put a 5y here, I get 5y. 5y minus 4y is 1y. So that's going to be my answer. All right, I'm going to get rid of these big swoops because I've got to finish factoring. Okay. Now I have, well, let's kind of zoom in a little bit, make it a little easier. All right, now I've got 5y times 2y is 10. It's a minus 2, so I have to have a negative and a positive. My larger has to be a plus because it's plus y. So 5 is the larger. So this one has to be a plus and that a minus. So that's my answer. 5y minus 2 times 2y plus 1. Okay, we're going to look at 3 now. No common factors. There's not an x in all of them, not a y in all of them, not a number in all of them. Okay, so I have x, but my y has a value on it, so there's going to have to be a coefficient on my y. 16, factors of 16. That add to 17. Well, that's 16 and 1. So, I have a 16 and a 1. I am adding them together so they're both the same sign, so they're both minuses. So I have x minus 16y, x minus y. Now, I will check this by multiplying. FOIL, x squared minus xy minus 16xy plus 16y. Well, this gives me x squared minus 17xy plus 16y. Oops, that was a squared. Squared. So check. Yes, that worked. Whoops. All right. Now, hopefully I notice this is not a trinomial, but a binomial, which means that I've got either a difference of squares or a difference or sum of cubes. In this case, it's x squared, so I've got a difference of squares. So this is 7x squared minus 1 squared. So my pattern is going to be 7x minus 1, 7x plus 1. Remember, conjugates. All right, let's look at 15. 4. These are both squares, so immediately I'm going to look for a sum of squares. But square root of 4 is 2, so I have a 2x and a 5y. Multiplied is 10 times 2 is 20. This does not fit the pattern. It's 29, not 20. Okay, so we don't have that pattern. So we're looking at factors of of 4, that when combined with factors of 25 will add to 29. Well, 25 and 4, don't they? That works. So I have to have 25y times 1 and 4x times 1. All right, I'm adding them together, so the sign should be a subtraction. So my final answer would be 4x minus 25y times x minus y. Oops, I went the wrong way. 6. 3y minus 4 minus 3xy plus 4x. 4 terms. This means I'm going to factor by grouping. All right, so I'm going to rearrange these to get them next to each other in patterns. Notice I have 2 terms with a 4 and 2 terms with a 3. So I'm going to put those all together. So I'm going to do 3 xy. Nope. I want my positive up front. So 3y minus 3xy plus 4x minus 4. That's what I'm going to do. Now I'm going to break these into binomials. I'm going to factor out. I can factor out a 3y out of the first one. And that's going to leave me with 1 minus x. And I can factor out a 4 out of my second binomial and get an x minus 1. Well, I have a small problem. Look at the fact that I've got these backwards. I've got a 1 minus x and an x minus 1. So that means I need to factor out a negative. So I'm going to do that because I like my variables to come first. I'm going to change this term. I'm going to change this into a negative. By putting a negative out front, I will flip the negative in here and flip them all around. All right, so it becomes negative 3y x minus 1. Okay, it became negative 1 plus x, but then I flipped those so they have the same pattern, the same order. So that makes it easier to see. Plus 4 times x minus 1. Now I can factor out the x minus 1. And I'm leaving behind a positive 4 minus a 3y. So I did a couple of extra steps in here. And come see me in class if you feel like you didn't understand it and need to see it again. It's just unfortunate that it was all backwards up in the first starting position. Seeing it now, it would have been better to do the 4s first and the 3s second, but I didn't see that up front. That's the way it happens sometimes. So much for the Girl Scout cookie. It just crumbles. All right, 7. All right, whoa. I see 2s in all of mine. Yep, 10 is 2 times 5. The others don't have 5, so 2 is the only thing in it. So I can factor out a 2. I'm left with 6x squared plus 7xy minus 5y squared. Remembering my 2 is going to be in this factor all the way through, I have, something x. It's either going to be 6 and a 1 or 2 times 3. and I have y's at the end. Now, those are going to be 5 and a 1. I need them to subtract to 7. Okay, aha. How about 5 times 2 is 10? I have a 5 times 1 and a 2 times 3. I'm going to get 10 and 3, and if I subtract them, I get 7. So that works. So 5 times 2, I have my inners, 5 times 2, and 10 times 3, 5 times 2 and 1 times 3. So here's my 1, and I have to multiply it times 3. Okay, so now let's see. Since I subtracted them, my larger has to be 7, so the 10. This one is the 10, so the plus goes here and the minus there. So my final answer would be 2 times 3x plus 5y times 2x minus y. That would be my final answer. All right, 50x plus 2x. Well, I can factor out a 2 and an x out of both of those. That leaves me with 25x squared plus 1. Those are both squares, but it's a sum. So it's not going to do me any good with squares and a sum. So that's considered prime. So I'm down to my prime factors. All right, that was easy. Just had to be careful. Okay, so cubes, binomial. I do have cubes. This is 2x cubed, and I'm subtracting 3 cubed. All right, so that's going to give me a same symbol, so minus 3 times a, which is 2x, so a squared, 4x squared, flip the sign, plus just a times b. So that's 3 times 2 is 6x. And then I have a plus b squared, which is 3, so that's 3 squared is 9. So that would be my final answer. All right, let's look at 10. No common terms. No squares in the numbers, so it doesn't fit any of my patterns. So I've got 7x. Now, I know it's a 7x and a 1x because 7 is prime. It only has 7 and 1 as a possibility. So now I have to have factors of 6 such that they subtract to 11. Well, that's not pretty. So how about 7 times 2 is 14, and then I subtract the 3. Yep, that works. So 7 times 2 minus 3 times x, or 3 times 1. Okay, now, different symbols. They're, the larger is negative, so that is my 14, 7 times 2. So the negative comes here, and the plus is there. 7x plus 3 times x minus 2. All right, and moving on to 11. Okay, I'm just checking. We're almost done. All right, well, isn't that fun? Now, 64 is a cube or a square, because it's 8 squared or 4 cubed. But 125 is only a cube. So I've got 4x squared cubed plus 5y cubed. So I'm going to use my pattern. I have the first term, 4x squared, same symbol, second term. That times the first term squared, 4 squared is 16, x squared is x to the 4th. Flip the sign, 4x squared times 5y gives me 20x squared y. And now the final term squared, so the 5y squared, becomes plus 25y squared. And that would be my factored form. This is a sum of cubes. All right. Oh, I'm going the wrong way. Sorry. There we go. 12. All right, two terms. 81 and 81. Well, those are 9 squared or 3 to the 4th, but we don't have a 4th. We only have thirds. We can only have to the 3 or to the 2. So this becomes 9x squared minus 9 squared. So I have a difference of squares. 9x squared minus 9 and 9x squared plus 9. And that's my final answer. All right. Oh boy, 4 terms. Woohoo! Now these have the w's in them already. So this one's pretty straightforward. I can factor out a 2w, and I'm left with w minus 2. Here I can factor out a 10, and I'm left with w minus 2. So I can factor out the w minus 2, and what's left behind is 2w plus 10. Okay, I'm sorry I had a little blip in my program here. All right, that's 13. There we go. Sorry. Okay. And 14. Let's see. This is 3x squared, and this is 8y squared. 3 times 8 is 24. 2 times 24 is 48. This is a perfect square. So I have 3x plus 8y quantity squared. Pretty easy, not too bad. All right, to get good at this, you just have to practice. I can give you extra practice in class if you need it. Just let me know, and I will bring some extra worksheets of factoring. It's just a matter of practice. Okay, have fun.